Hi, everyone. Good evening. My name's Ian Sewing. I'm a professor in the Department of Earth and Environment. I do work on climate change impacts, and this work is a sample of stuff that we're doing on technology adoption as climate adaptation, and it's joint with Erin Manser at Dartmouth College. Next slide, please. Um, we're trying to explain this picture, which is in India, and note that there's a generator, and the exhaust of the generator is going into the intake of air conditioners. Uh, this is a metaphor for the fact that, next slide, please, we may be adapting to climate in a way that makes climate change worse. Climate change has energy system impacts because it increases demand for space conditioning, particularly cooling on net, and that's going to coincide with an increase in penetration of air conditioning in developing countries and large increases in electricity consumption. And it depends how we generate that electricity, whether or not we'll get much more carbon dioxide from emissions from fossil fuels, and whether our adaptation will cause a positive feedback to the thing to which we are adapting. How do we understand this in developing countries? Well, we look at countries that have adopted AC before, and the United States is one such country. Next slide, please. Where throughout the 60s and into the 80s, you had an enormous increase in air conditioner penetration. And we can record those by looking back at census microdata for the period. We see preliminary evidence that there's a very strong latitudinal gradient in adoption. And we are getting a period shown in pink on the graph, which is just at the inflection point before the run-up and saturation of AC in many parts of the country. Next slide, please. What we do is we take the data in census microdata and pair it with measures of exposure, cooling degree days, which we construct from reanalysis data. And we have a data set of over 3 million households in 251 cities over 2 decadal waves. The idea here is we need to understand the joint decision to both adopt AC and then conditional upon adoption, increase utilization. And that's a McFadden-Dubin discrete continuous sort of model that's shown here. Next slide, please. When we estimate the model and we actually force the model with the increase in heating and cooling degree days over the subsequent period up until now, we find that historical warming, as small as it has been in the United States, has driven 1/3 of the AC adoption that we have seen in the country. Not surprisingly, much of this has been in the South in blue, but surprisingly, where there's the least amount of AC in the country, it has been in the West, many Western cities. And so we identify the Western cities as the canary in the coal mine. Next slide, please. In terms of implications for what this might mean for developing countries, looking at the United States past as the prelude to what might happen in places like India, China, Turkey, South Africa, Brazil. We combine our estimated responses with projections of CDDs and HDDs from Petrie and Caldera. We find that a 1 standard deviation increase in mean climatic degree days, cooling degree days, causes about 37% more adoption. And we want to take these numbers to the data for developing country projections to understand what that might mean for developing countries. We can do a little test in the United States to see what that means. Boston out to the end of the century relative to the end of our sample period will shift in its climate from 1980 New York to 1980 Jacksonville, North Carolina, and that will result in 50% higher AC penetration. In terms of the energy use conditional on that AC penetration, what you see is it's very nonlinear. You have very little demand amplification in cool cities with cool climates. But once you get above the median, the increase in heat exposures explains 50% of the intensive margin adjustment of energy consumption, and that's concentrated in the hottest cities where AC penetration is already saturating. And just again, as an example, Chicago, Illinois shifts toward the end of the century from 1980, the climate of New York in 1980, to the climate of El Paso in 1980. And that sort of change results in a 60% increase in AC penetration, a factor of 4 increase in energy consumption conditional upon penetration, and a doubling of total electricity use. And that's it. Next slide for the introduction, and I will pass it on to the next speaker. Thank you so much.